In this video, we're going to talk more about special solutions. We're going to look at a little bit harder of problems, but the results are going to be the same. If we have an x in our answer, there is one solution, and my one solution is that number. If I am left with no variable, so for example, if I'm left with 2 equals 2, or 0 equals 0, or 5 equals 7, okay, these are special solutions. Because just like we talked about in our last video, either they're gonna, if I'm talking about money, the two such scenarios are always gonna be costing the same amount, or I'm gonna have the same amount saved, or they're never gonna be the same. Now, if I look at these examples, which one is infinite solutions and which ones are no solution? Hey, these two are infinite solutions because they are the same on both sides. Because this statement is true, 2 does equal 2, 0 does equal 0. This is no solution because 5 does not equal 7. They are not the same number. They do not have the same value. So in the special solution category, I have two different types, infinite and no solution, and I'm comparing to see if those statements are true. Let's go ahead and try a few examples. So 4 times v minus 1 plus 7 equals 5 times 2v minus 3. All right. I'm drawing my line. There's a lot going on. I have to simplify before I can make any decision. So let's go ahead and simplify. 4 times v is 4v. 4 times negative 1 is minus 4. Bring down the positive 7. Okay, go to the other side. Simplify it as much as I can there. 5 times 2 is 10v. 5 times negative 3 is negative 15. Go back to the left. Can I simplify any further? Yes, I can. I've got these separated terms. 4v, there's nothing like it, so I bring it down. But negative 4 and positive 7 can combine to give me positive 3. And I'd recommend using calculator if you're not fluent with your adding and subtracting of integers. Equals 10v minus 15. At this point, I'd make the comparison and try and decide if it's going to have an infinite or special solution. Since my variables are different, it should have a solution. So this variable side is bigger, this is smaller, so I'm going to get rid of the 4v. And that zeroes out, and I'm left with 3 is equal to 10 minus 4 is 6v minus 15. Hey, how do I go about solving this? If this is my variable side, get rid of the 15 plus 15. 3 plus 15 is 18. Left with 6v, that zeroes out. Divide by 6, because that's multiplication, and 18 divided by 6 is a grand total of 3. So 3 equals v. There's my variable. This has one solution, and 3 is it. Okay, let's look at a different example. Draw my line, simplify both sides. So negative 3 times x is negative 3x. Negative 3 times 1 is negative 3 plus 7x. Notice I don't keep distributing because I'm done with my parentheses. Equals 4 times x is 4x. 4 times 1 is positive 4. I stop multiplying, bring it down. I separate out my terms on my left side. I'm going to ignore the right side for now. Combine anything that's alike. Negative 3 and 7, those are alike. That adds to a total of 4. Negative 3 doesn't have any like terms, so I bring that down. Equals, separating out my terms, 4 is on its own. 4 and negative 7 give me negative 3. If you notice, they're exactly the same on both sides, so I'm going to hold off. I think infinite solutions, but I'm going to hold off on writing it. I'm going to prove it with algebra. If this doesn't matter which side is your number side, which side is your variable side. Let's say we make this our variable side, get rid of the variable on the side, 4x, minus it on both sides. I'm left with negative 3 equals negative 3. Remember, infinite solutions are when I have a true statement. Negative 3 is equal to negative 3. So right now I can claim infinite solutions. If you made your variable side the other side, you probably ended up with 0 equals 0. That's also a true statement, and they both mean infinite solution. Okay, let's try one more. Drawing our line, simplifying both sides. Distribute. 2 times y is 2y. 2 times -3 is -6. Bring down the -5y. And on the right-hand side, I'm going to distribute. -3 times y is -3y. -3 times +3 is -9. So do what I can do to combine like terms. 2y and -5y combine to give me -3y. And -6. -3y and -9. I notice that if I look at those terms, they do not combine. Draw my line. Let's prove our answer with algebra. I think, let's just prove it with algebra. So let's say we make this our variable side. I'm going to get rid of our 6, so plus 6. Ooh, make sure you add it to the constant, not to the variable. I am left with, I'm going to bring it up here, -3y is equal to, that's gone, -3y minus 3, because that equals -3. If this is my variable side and this is my number side, I'm going to get rid of the 3y. Hey, notice that the variables cancel out. There's a big fat 0 over here. That zeroes out. There's not a big fat 0 over here because I have this -3 remaining. If I look at this equation right here, 0 does not equal -3. This is a false statement. So there is no solution. All right. If you have any questions, please reach out. Your assignment is on Alex. Good luck.